Okay, I'm going to do this semester exam review in several parts, and so this is part 1, which is going to cover through probably through that domain page, so this will take you through number 30. Okay, so let's take a look at our first part, which is on our different functions, and so here are the different types that I want to see if you can tell me that we're talking about here. This first one, of course, is going to be other. That looks like our sine or our cosine function. This second one is going to be our square root function. The third one is actually a reflection of number 2, a reflection over the x-axis, so that one also is a square root function. Okay, the fourth one is going to fall into our exponential or log, and I got a question earlier today, how can you tell the difference between exponential and log? Well, what you would have to do is determine where your asymptote is. And so if your asymptote is going to be crossing over the y-axis, then it's y equals a number. And in this case, y equals 0. Those are the ones that are exponential. This would be exponential. This has a domain that is not limited. Now take a look at this square root function. See, your domain is going to be limited. Your domain is going to be limited on your square root function. All right, next. Number 5, 6, 7, and 8. So those, number 5, this one, of course, is a quadratic. It's a reflection. This one, of course, is linear. This one is logarithmic. And see, this one has an asymptote that is crossing over the x-axis. So this one would be x equals whatever number it's going to be crossing over. And then here, this is the reflection of it. This one also has that x equals a number, so it's also logarithmic. Okay, so then our last one over here, this one has an asymptote here, so this one is exponential. Okay, so that's how you can tell a difference between those. All right, what type of functions are inverses of each other? Well, the square root functions and the quadratic. Of course, we learned quadratic first, and then we talked about its inverse. So quadratic and square root, and of course, you know, you only see a portion of the square root at a time. And then the other ones that are inverses are exponential and logarithmic. Okay, so our exponential being like this, and then our logarithmic is going to be taking this. So see, they are reflections across that line, y equals x. Okay. Next section, number 11. Which of these problems have an asymptote? Well, we already talked about those. Those would be the exponential and log ones. So that's numbers 4, 7, 8, and 9. And then which of the above problems have a maximum or a minimum? That's that one that has the vertex, that quadratic, number 5. Number 13, which pairs of the above graphs are reflections of each other? 2 and 3 are reflections. I already talked about that. That's the quadratics. 4 and 9 are reflections of each other. And then 7 and 8 are reflections of each other. Okay, so next page. This is a page that I think is pretty challenging. So I do have a bit of information. You have got to do this. And they help you to make a rough sketch of that function in order, and its transformations, in order to know its domain, range, and asymptote. You just really have to do that. So I'm going to demonstrate that on all of these. Maybe not all, but hopefully you'll be able to get the idea of, I'll model how to sketch those. Additionally, you need to keep in mind this fact that your exponential functions and your log functions have asymptotes. And since those have asymptotes, they approach a value and never actually reach it. And therefore, you are not going to have brackets. You are going to have just the parentheses on those exponential and logarithmic functions because they have an asymptote, so just parentheses only. Whereas the other ones, like square root, quadratic, linear, they will have, well, linear doesn't, but the others will have brackets. Okay, so let's take a look at number 14. Here's a sketch. Here is the parent function of a square root, and this is a k value. I'm shifting it up 5. So therefore, there's that function. Its domain includes this 0, so it is a bracket here, 0 to infinity. The range, it stops there at 5, so it is going from 5, you do it from least to greatest, 5 to positive infinity, and it does not have an asymptote. Square root functions do not have asymptote. Our domain of number 15, well, let's sketch that. Okay, so let me do the parent functions. Let me do these other ones in a different color. So here's the parent function. What is this minus 6 going to do? It's an h value, so I'm going to shift it left 6. And k value is going to shift it up 3. So there it is, left 6 and up 3. So its domain is going to go from this left 6 minus 6 to infinity, including it. The range is going to go from 3 to infinity, including that 3. And it also does not have an asymptote. Okay, look at number 16. What type of function is number 16? Where's the variable located? Well, since the variable is located in the exponent, it's an exponential function. So this 3 is an h value, so the parent function of the exponential looks like this, but that 3 is a h value, and I want to shift it left 3. So let's say that I've got this shifted left 3. So my domain is negative infinity to infinity. My range, it has a asymptote there at 0, but it's crossing over the y-axis, so it's y equals 0. And so its range is going from 0, but it's approaching it, so it's a soft bracket. It will never actually reach 0. From 0 to infinity. Okay, so let's look at what the next one's doing. What type of function is number 17? Number 17 is an exponential function. So I have the parent function as an exponential. But now what is this plus 3 doing? That is not an h like it was in number 16, but rather a k value. So therefore, it shifted it up 3. Remember, the k does exactly what you think it should do. All right. So my domain is going to go from negative infinity to infinity, as all exponential functions do. And since I had a k value, it's going from 3 to infinity. And it is crossing the asymptote, is this line here, crossing over the y-axis at 3. So it's y equals 3. Okay, so then the number 18 and 19 are logs. They're done a similar way as the other one was. So here's my log function. Here's the parent function of the log. What's this plus 3 doing? It's a k value. So since it's a k value, I'm going to shift it up 3. My asymptote is still right here. So my domain is limited. My domain is going from 0 to infinity because the asymptote is on the graph at crossing over the x-axis at 0. So my asymptote is x equals 0. My range is going to be negative infinity to infinity like it is on all log functions. Okay, number 19. This is going to be a parent function of a log, but what's this? An h value, shifting it right 3. So that actually looks like this. Here is my asymptote crossing over the x-axis at 3. And so then my domain is going from 3 to infinity. My range is, as with all logarithmic functions, negative infinity to infinity. Okay, so I've modeled through several of those. I'm not going to do all of them, but I'll do this one quadratic here. Here's a quadratic shifted up 3. So it's looking like that. So we have a domain that is going to be going from negative infinity to infinity, as with all quadratics. And the range includes 3 because there was no asymptote. It includes 3. No asymptote. Okay, this one here, number 21, I'll just go ahead and start putting up some of these answers because I'm not going to do all of those. Negative infinity to infinity. The range was negative 3 inclusive to infinity. No asymptote. Number 22 is linear. So that's negative infinity to infinity on both. And of course, since you have infinities, you are you got parentheses because you can't ever reach infinity. Okay, number 23 is going to be negative infinity to infinity. And it is a reflected quadratic. So look at what the range is doing. It's actually going to be going from negative infinity up to 3. And then there our bracket is on 3. That way, your range, well, both of these in interval notation is always going from least to greatest. And there was no asymptote there. Okay, now 24. Let me do 24, 25, and 26. Let me demonstrate 24, 25, and 26, and then I'll just put the answers up for the rest. So here's 24. So say this is our graph. What type of function is 24? It's exponential. And so here's the parent function of an exponential. Now reflect that exponential because of this here. So there's my reflected exponential function. Now do what with it? Now shift it up 3. So here is the final version of my exponential reflected and shifted up 3. So my domain is going from negative infinity to infinity, as all exponentials do. Negative infinity to 3. It's approaching 3 but not reaching it, so it's a soft parentheses, not a bracket. And that asymptote was crossing over the y-axis, so that is y equals 3. Okay, number 25 is a log. And so you start with the parent function of the log. And then because of this negative, we're going to reflect it. So that's going to look like this, reflected. And then go down 3. So that will be this. Kind of getting it all squinched in there. So that will be that. So my domain is going to be from 0 to infinity because my asymptote is x equals 0. And then my range is still from negative infinity to infinity. Okay. So number 26, I'll do, this is the last one I'm going to demonstrate. Number 26 looks like this. We have a square root function, and it is reflected. It is shifted left 3 and down 4. So there it is. So this is left 3. So that affected my domain. So my domain went from negative 3. Remember, it included it because square root ones include it. Only exponentials and logs are soft all the way around. And the range is going from negative infinity up to and stops at negative 4. And there's your bracket. And there was no asymptote on that. Okay, so let's give you the answers for 27. So for 27, it's a bracket 0 to infinity, and then negative infinity to negative 4, bracket, no asymptote. 28, negative infinity to infinity, negative infinity to infinity, so that was linear, so it was just all real numbers all the way around. Okay, so then let's go ahead and scoot that and get the last little bit of this. Number 29, negative 3 to infinity, because it was shifted left 3, and the range, negative infinity to infinity. Our asymptote is x equals negative 3. And the last one, don't forget that this is an exponential decay, so if you were looking at this, this would be a decay function shifted down 3. Okay, so there's the dotted one. And so there's our asymptote. It's an exponential decay because that base, if this base is between 0 and 1, then it's a decay. All right, so there's all of that, and I'm going to stop there. This is the end of the first part. Part 2 will take you, well, actually, you know what? I think I will go ahead and go on to the next page because it's still, this is still no calculator. So let's go ahead and finish up this no calculator part. We'll go ahead and go to the next page. Okay, so here you're just shifting them around and you're matching them. This one is D, A, C, B. I think that was pretty straightforward. Remember that these A values stretch. This one compresses, makes it flatter, and it reflected it, so that's why that was B. Okay, next, I think we had a little bit more trouble with this next set, number 35 through 38. What you have to remember is that this 8 value here, that becomes apparent. Remember this in chapter 8. That shows up on the y-axis. So this 2 here, this will show up on the y-axis. So, let's see here. Let's take a look at those. This one is, and this, you know, by the way, these A values here are 1. So each one of those, number 35 and 36, so that has a y-intercept of 1. This one has a y-intercept of 1. This one has a y-intercept of 3. And why does that happen? Why is that happening? Well, because at that point, x is 0, and that 0, when you put a 0 in right here for the exponent, 2 to the 0 is 1. And so then what becomes apparent? That y-intercept. So that's what's happening. So look at these y-intercepts. That's important. That's going to be able to be told through our y-axis, our A value. Okay, so number 37 has a y-intercept of 3, and that ends up being B right here. 38 is one of the ones with a 1. And so that's A or B. A has a y-intercept of 2. So I can tell that then that's number 38. Okay, so now I have to compare C and D. They both have a y-intercept of 1. And 35 and 36 both have a y-intercept of 1. What's the difference between 35 and 36? This one has a growth of 2. This one has a growth of 2.718. So what's going to be a steeper growth? The 2.718. This one has a steeper growth, so it has a steeper base. Okay, you remember that? So therefore, I would say this one's the e to the x, and this one's the 2 to the x. Okay, so therefore, The answers for that puts this at D and this second one as C. All right. Next section is quadratics, and this represents all three different forms. This first one is standard form, and what you have to do is get the x value of the vertex is negative b over 2a. I expect you to have that memorized. But I actually can tell that one just because it's the only one that has a positive a value. If it's the only problem with a positive a value, what's its parabola going to look like? It's going to be increasing like this. So therefore, I know this is b. This one is in vertex form. So that tells me there's my h and there's my k. So my vertex of this should be 1, 8. So which one has a vertex of 1, 8 and is a negative parabola? And that looks like it will be this one, A. And then the last one, this is intercept form. And what do you know from the intercept form? You know your P and your Q. This is P, so P is 3. This is Q, so Q is negative 4. So I'm looking for roots that are 3 and negative 4. So that would be C. All right, next, number 42. So what I did on this one was to find my first one. I did my, see this is saying 2 to the y equals x. And so let's do the inverse. The inverse is 2 to the x equals y. Then I make a little table of it. And so 2 to the 0 is 1. 2 to the first is 2. So then I come back here and I say, okay, well what that means is I need to switch it back to my log function. That would be 1, 0, 2, 1. So 1, 0, 2, 1. So this one is A. Okay, from then on out I just do my shifting. This one goes up 3. Which one goes up 3? This one here. This one is going to take me left 3. Which one goes left 3? That would be this one here. And this one goes left and down. So, well, this one is just left 3, and then this one is left and down. So I've got C and D there, or D and then C. All right, so that's the end of the non-calculator portion of the test that you will be doing.